Today we are talking about what are called higher order derivatives. Higher order derivatives. What that means is derivatives beyond the first derivative. Because there are derivatives beyond the first derivative. Okay? So, this is the first derivative right here. Shh. How do you read this?
I don't know what that is.
F prime of x. F prime of x is the first derivative. Okay? There is a second derivative that is written this way. F with two of those little marks, two little apostrophes. That is called the second derivative. And the way you read it is F double prime of x. So the first one is F prime of x, and the second one's called F double prime of x. Double prime. And what it means is the derivative of the derivative. Okay? So let's take a simple problem. F of x equals, listen to what I'm saying, F of x equals x squared. What is F prime? What's the first derivative? 2x. What's the second derivative? 2. What's the third derivative? 0. And so on and so on. Does that make sense to everybody? You just take the derivative of the derivative of the derivative and keep going. Okay. Now, here's a couple other ways to write it. You know that y is the original function. Y prime is the first derivative. Y double prime is the second derivative. You just write two of them up there. This is y double prime. Okay? And if dy dx is the first derivative, the second derivative for dy dx is really strange looking. I don't know who made it up or why. We just go with it. And it's one that you need to be familiar with. Here's how it looks. D squared y over dx squared is the second derivative of y. D squared y over dx squared, that means second derivative. So if you see that right there, that means take the second derivative of whatever your function is.
What is that called?
It's called d squared y over dx squared. That's the only. It doesn't have a real name. You just read it.
Why is it squared?
I don't know. That's what I think is so strange. I think that if they wrote dy dx squared, that would take the derivative and square it. So they had to make it different so that it didn't get confused with that. I don't know. Okay. All right, here is the question I'm going to ask you. Find f double prime of x for f of x equals 6x squared minus 3x minus 1 over the fourth root of x to the fifth. Find f double prime of x for f of x equals 6x squared minus 3x minus 1 over the fourth root of x to the fifth power. Okay, this means I've got to take the derivative twice. So, in order to take the derivative, are all three of these in the correct format to take their derivative?
No.
Which one is not? The last one. So the first thing I'm going to do is recopy the problem, and I'm going to fix that last term. So 6x squared minus 3x minus 1 x to the what power is that? It is negative because it's in the denominator. Power over root, so it is going to be 5 over 4.
Why would you?
Okay? Now we're going to take the first derivative. So the first derivative would be, what's the derivative of 6x squared? 12x minus 3. Now be careful. The negative 5/4 comes down and multiplies to the negative 1, so it becomes a positive 5/4 x to the what power? No, negative 1/4 is going up. I need to go down. Negative 9/4. Negative 9/4. Now, for some of you that comes very easy. For others, it's going to take a little work. Let me show you how I got that. Negative 5/4, you're supposed to subtract 1. I'm going to put 1 over 1. And then change both of those into 4s, getting common denominators. So it's negative 5 and negative 4, which makes negative 9. Okay? Are we good so far? Okay, now we need to take the derivative again. Second derivative. Okay? What's the derivative of 12x? 12. What's the derivative of negative 3? 0. Now here, see these two fractions? What am I supposed to do to them? Multiply them. So remember, when you multiply tops and bottoms. So it's going to be negative 45 over 16, and then x to what power? It's going down again. Negative 13/4. Very good. So now, since I started out with radicals, I need to end with radicals. So I need to put that back in a radical to finish. So f double prime of x equals 12 minus 45. Go ahead and just write the fraction down first. And then think about the x. Should it go in the top or the bottom? Why? Because it's a negative exponent. It has to go in the denominator. So I'm extending that. Put the radical with the x. What's my root number?
4.
It's a 4. And the exponent is 13. And that's finished. That is the second derivative of the function we started with. Questions?
So is this like help me calculate the number of cells in my body, or what is this doing?
It does lots of different things, but right now we're just learning the mechanics. That's coming in the next unit, okay? I promise. Now, okay, the next thing we're going to talk about are what are called horizontal tangents.
So it's root over power.
Power over root. Power over root. Roots of a tree are on the bottom, so the root number goes on the bottom. Okay. Now, do me a favor, please, and picture in your mind a parabola. A parabola graphed on a graph that is a function. Does it have a horizontal tangent line? Think about it. Would it have a horizontal tangent line? Okay, depending on how you drew your parabola, it's either going to be at the very top of it or at the very bottom. So what do those 2 points have in common? They are the what? They're the vertex of your parabola, agreed? So, okay, a horizontal tangent is a line tangent to a graph, tangent to, oops, I messed up, tangent to a graph, decided to change my notes and then I messed them up. Whose slope, what's its slope? What's the slope of a horizontal tangent line?
0.
Is equal to 0. It's a line tangent to a graph with a slope of 0. So, you're going to be asked to find on a different kind of graph where the horizontal tangents are going to be. So let me show you. Find where, without a calculator, f of x equals x cubed minus 6x squared plus 1 has a horizontal tangent. Okay? I'm going to move this up. Find where this function has a horizontal tangent. Okay? What makes calculus a little harder than any other math is they don't always come right out and tell you what to do. They will say, they don't say factor that's problem, solve that equation. They'll say something like this. Well, what do you do? 2 things you need to notice right here. First of all, it says the word tangent. And tangent lines, we've always had to deal with derivatives. Okay? And horizontal means something about its slope being 0. So I'm going to change colors for just a second and talk about this. We're going to have to take the equation, we're going to have to take the derivative of this function to find the slope. And do you think that we're going to plug in 0 or set it equal to 0? Think about it. It is to set it equal to 0. We're going to take the derivative and set it equal to 0, and that's going to tell us which points have a slope of 0. Because remember that the derivative means the slope, so we'll take the derivative to find the slope. and then set it equal to 0. So let's take the derivative of that equation. Come back up here. What's the derivative of x cubed? 3x squared minus, what's the derivative of this? 12x. And we're supposed to set it equal to 0 when we're looking for horizontal tangents. Now, how do you solve that? This is algebra now. That's quadratic formula will work, but there's an easier way in this problem, in this specific one. We already took the derivative. Take out the x. Okay, I can pull an x out. Can I pull out anything else? How about a 3? Okay. What's going to be left? An x minus 4 equals 0. Now what?
X equals 4.
You set them both equal to 0. And you get x equals 0 and x equals 4. So what this is saying is if I graph this thing on a calculator, the two horizontal tangents would be at x equals 0 and x equals 4. But since it says find exactly where, I need to know the x's and the y's. So I'm going to come out to the side and I'm going to write 0 comma something and 4 comma something. And I'm going to find those somethings. Now, how do I find them? Okay, plug it in. It is not an acceptable word in this class. We need to get used to that.
The x value
Plug
into
which equation? The original. We're looking for y values. This is y. So when you plug it in here, 0 is going to be 1. And this one's going to be negative 31. I'll tell you that right now. I've already done the math. Okay. I'm done with that. So, plug the 4 into here, do the math. It comes out to negative 31. To finish up, let me just show you one thing. I've already graphed this on my calculator. There it is right there. How many horizontal tangent locations do you see? I see 2. It's supposed to be at 0 and 4. Let's trace and see. Trace 0. Yep, there's the first one. Trace 4. There's the other one. See how that works? There they are.
We're done?
We are done.